August 1st, 2012, 9:30 a.m., New York Stock Exchange. In exactly 45 minutes, Knight Capital Group, one of the world's largest trading firms, lost $440 million. Not from hackers, not from fraud, not from market manipulation, from a single line of code that shouldn't have existed. A deployment script that failed silently. An engineer who forgot to check one server, and by 10:15 a.m., the company was bankrupt. $440 million. Gone. In the time it takes to watch a sitcom episode. Now imagine that same scenario. But instead of a trading firm, it's your bank. And instead of losing money on the stock market, it's losing your paycheck. Every single employee, every direct deposit, every automated payment, every mortgage, every rent check. Gone, not tomorrow, not next week. Today, in 14 minutes. This is the story of Marcus Webb, a Level 2 IT analyst at one of London's largest retail banks, who discovered a catastrophic failure in the payment processing system on the morning of the biggest payday of the year. And he had less than 15 minutes to stop it before $2.3 billion in salaries vanished into the digital void. This isn't fiction. This is the kind of disaster that almost happens every single day, and you never hear about it. Because when someone stops it, nobody gets to write the headline. Stay with me until the end, because what Marcus discovered wasn't just a technical glitch. It was a systematic vulnerability that exists in almost every major bank in the world right now. And the terrifying part, most of them don't even know it's there. Before we dive into this story, I need you to understand something. The financial system you trust, the one that holds your money, processes your payments, transfers your salary, runs on code written by people who are overworked, underpaid, and operating under impossible deadlines. Every single day, there are people like Marcus who catch catastrophic failures seconds before they destroy millions of lives, and nobody ever hears their names. This is Quiet Collapse, where we tell the stories of the invisible disasters that almost destroyed everything. If you want to understand how fragile our systems really are, hit that subscribe button now. Share this video with someone who thinks the system just works, because by the end of this story you'll realize it only works because of people like Marcus, people nobody knows, people nobody thanks, people who are the only thing standing between normal life and absolute chaos. Let's begin. Friday, November 30th, 2018, Canary Wharf, London, Sterling Universal Bank, Data Operations Center. 7:43 a.m. GMT. Marcus Webb sat in his grey cubicle, drinking his third coffee of the morning, staring at 6 monitors displaying more dashboard metrics than any human should reasonably track. He was 34 years old. He'd been working at Sterling Universal Bank for 11 years, started as an entry-level database administrator right out of university. Now he was a senior systems analyst, which sounded impressive until you realized it basically meant the guy who gets called when everything's on fire and nobody else knows what to do. Marcus had learned early in his career that banking IT operates on a simple principle. If something works, don't touch it. If something breaks, fix it fast, and don't ask questions. The less people knew about the fragile infrastructure holding together trillions of pounds in transactions, the better everyone slept at night. His morning routine was always the same. Arrive at 7:30 a.m., check the overnight batch processing logs, make sure the automated payment systems completed their nightly runs, verify that customer account balances reconciled correctly, confirm that all 47 interconnected systems across 12 different legacy platforms were still talking to each other. Pray, nothing broke. On most mornings, everything was green. System status, nominal. Transaction throughput, normal. Error rates, within acceptable parameters. But this morning was different, not because anything looked wrong, but because of what day it was. November 30th, last business day of the month, which meant monthly salary payments for approximately 4.2 million customers. Automated bill payments, $680 million. Direct deposits, $1.6 billion. Standing orders and transfers, $340 million. Total, 2.62 billion moving through Sterling Universal's payment infrastructure between 6 a.m. and 9 a.m. The single largest concentrated payment processing window of the entire year. Marcus had been through this before. Every month end was stressful, but manageable. The systems were designed for this volume, redundancies in place, failover mechanisms tested, load balancing protocols tuned. Everything had been working perfectly for 18 months straight, since the last major infrastructure upgrade. Since they migrated the core payment processor from the old COBOL mainframe system to the new cloud-based microservices architecture. Modern, scalable, fault-tolerant, or at least that's what the consultants said when they signed off on the $84 million modernization project. Marcus pulled up the payment processing dashboard. Status: processing. Batch started 06:03 GMT. Current time 07:43.29 GMT. Elapsed 1 hour 43 minutes. Expected completion date 45 GMT. Progress 68.3% complete. Everything looked normal. Transaction rate 14,230 per second. Error rate 0.0003%. System load 72%. All within normal parameters. Marcus leaned back in his chair. Maybe today would be uneventful after all. Then his phone buzzed. Text message from Rachel Kim, Senior Payment Operations Manager 2 floors up. Marcus, can you check the outbound Swift gateway? Dashboard shows degraded, but I'm seeing successful transactions. Probably just a false alarm, but confirm. Marcus frowned. The Swift gateway handled international wire transfers. If that was showing issues on a month-end Friday, it could cause delays for corporate clients sending payroll to overseas employees. Not catastrophic, but annoying. He pulled up the Swift gateway monitoring panel. Status degraded. Current throughput, 89% of baseline. Latency, pulse 340 milliseconds above normal. Error rate, 0.2%. Not great, but not terrible. Probably just network congestion from the high transaction volume. Marcus typed back, seeing same. Latency spike, but nothing alarming. Likely just volume. Keep monitoring. He switched back to the main payment processing dashboard. Progress, 69.1%. Still normal. Then he noticed something odd. One of the secondary monitoring panels, usually tucked away in the corner, was showing an alert he'd never seen before. A small yellow triangle icon. Warning level, low. Message: transaction reconciliation queue 3047 pending. Marcus tilted his head. Reconciliation queue? That shouldn't have any pending items during an active batch run. The reconciliation system was supposed to validate transactions in real time as they processed. Having pending items meant what exactly? Transactions that processed but hadn't been confirmed yet. Marcus clicked into the detailed view. The queue was growing, 3,847 pending, then 4,012, then 4,339. In less than 30 seconds, it had jumped 500 items. That wasn't normal. Marcus opened a terminal window and queried the reconciliation service directly. The response made his stomach drop. Pending transactions, 4,822. Oldest pending, 47 minutes ago. Average processing time, 0.3 seconds. Current processing time, timeout, no response. No response. That meant the reconciliation service wasn't processing anything. It was just accumulating items for 47 minutes. Marcus's hands moved faster now. He checked the reconciliation service status. Status, running. CPU usage 2%. Memory usage 14%. It was running, but not doing anything. Then Marcus checked the error logs. What he saw made him go cold. 07:43:451. Error. Database connection pool exhausted. Retry attempt 1 to 3. 07:43:52. Error. Database connection pool exhausted. Retry attempt 2-3. 07:43:53. Error. Database connection pool exhausted. Retry attempt 3-3. 07:43:54. Critical. Unable to establish database connection. Transaction validation suspended. 7:43:54. Warning. Pending queue exceeding threshold. Current 4,891, database connection pool exhausted. That meant the reconciliation service couldn't connect to the database where it stored transaction confirmations, which meant every transaction that had been processed in the last 47 minutes hadn't been validated. They'd been executed, money had moved, but there was no record of it, no confirmation, no audit trail, no proof that the transactions had actually happened. And in 62 minutes, when the batch processing completed, the system would try to reconcile all those pending transactions at once. And when it couldn't, Marcus grabbed his phone, dialed Rachel Kim directly. It rang once, twice, 3 times. Come on. Marcus, what's up? Rachel, we have a problem. How fast can you get to my desk? Let me pause for a second, because right now, you're probably thinking, okay, so a database connection failed. They'll just restart it. Problem solved. But here's what you need to understand. Modern banking systems aren't like the apps on your phone. You can't just turn it off and turn it back on. These systems process millions of transactions per hour. They're interconnected with hundreds of other systems across dozens of institutions, and they're built on legacy code that's been patched, updated, and duct-taped together for 40 years. Restarting one service could trigger cascade failures across the entire payment network, which is exactly what's about to happen. This is quiet collapse, where invisible people stop invisible disasters. If you're finding this valuable, hit that like button and subscribe, because the next 45 minutes of Marcus's life are going to show you just how close we all are to financial chaos at any given moment. Let's continue. Rachel Kim arrived at Marcus's desk 4 minutes later. She was 42, razor sharp, and had been in payment operations for 18 years. If there was anyone Marcus trusted to understand the gravity of a situation immediately, it was Rachel. "Show me," she said. Marcus pulled up the reconciliation queue. Pending items, 7,234. Rachel's eyes widened. How long has it been like this? Started about 50 minutes ago. The reconciliation service lost its database connection and just stopped validating transactions. But the transactions are still processing. Yes, that's the problem. Money is moving. But there's no record of it, no confirmation, no audit trail. Rachel leaned closer to the screen. What happens when the batch completes? Marcus pulled up the system architecture diagram. When batch processing finishes, the main payment processor sends a completion signal. That triggers the reconciliation service to close out all pending items and generate the daily settlement report. And if there are 50,000 pending items with no validation data, the reconciliation service will fail to close, which means the settlement report won't generate, which means the batch will be marked as incomplete, which triggers the automatic rollback protocol. Rachel's face went pale. Rollback, as in undo all the transactions? Exactly. Marcus, we're processing $2.6 billion in payments right now. If the system rolls back all of them, every direct deposit sent this morning gets reversed. Every bill payment, every mortgage payment, every rent check, all of it. Rachel grabbed her phone. "I'm calling Trevor. We need senior management on this now." Trevor Hollis, Chief Technology Officer, the man who signed off on the $84 million infrastructure modernization project, the man who assured the board that the new system was more reliable, more scalable, and more resilient than anything we've ever had. The man who was currently on holiday in the Maldives. Rachel put her phone on speaker. It rang 6 times before Trevor answered. "Rachel? It's 2:02 a.m. here. This better be..." "Trevor, we have a critical failure in the payment reconciliation system. Batch processing is still running, but we've lost transaction validation. If we don't fix this in the next hour, we're looking at a full rollback of $2.6 billion in payments." Silence. Then, "What do you mean lost transaction validation?" Marcus spoke up. "The reconciliation service can't connect to its database. It's been accumulating unvalidated transactions for the last hour. When the batch completes, it's going to fail the closeout process and trigger automatic rollback. That's impossible. We have redundancy protocols, failover mechanisms. The system should have automatically switched to the backup database connection. Except it didn't. Another pause. Okay. Don't panic. What's the batch progress? Marcus checked. 74.6%. About 50 minutes until completion. Can you restart the reconciliation service? Not while the batch is running. Restarting mid-process could corrupt the transaction queue. Then restart the database connection pool. Same problem. We can't mess with database connections while active transactions are in flight. We could lose payment data. Marcus could hear Trevor's frustration through the phone. So what you're telling me is, we have a system failure that we can't fix without potentially making things worse, and if we do nothing, it's definitely going to make things worse. Yes? Christ. Okay. I'm going to conference in Dimitri from infrastructure. Hold on. The line went silent. Rachel looked at Marcus. How bad is this really? Worst case? The rollback fails and we end up with duplicate transactions. People get paid twice, or their accounts get debited twice, or payments just vanish. The database integrity could be completely compromised. And best case? We figure out how to manually reconcile 50,000 transactions in 45 minutes without shutting down the payment processor. Rachel's expression said it all. That's impossible. The line clicked back on. A new voice, thick Russian accent, clearly just woken up. This is Dimitri. What is problem? Trevor explained the situation. Dimitri's response was immediate. This should not happen. Reconciliation database has automatic failover. If primary connection fails, secondary should activate within 2 seconds. Marcus jumped in, except it didn't, and I think I know why. He pulled up the database cluster configuration. When we migrated to the new microservices architecture 18 months ago, we moved the reconciliation database to a managed cloud service, primary instance in London, secondary instance in Frankfurt, automatic failover configured. Yes, I set this up myself. Is solid design. Except, Marcus highlighted a specific configuration setting. The failover trigger is based on instance health checks. If the primary instance is still responding to ping requests, failover doesn't activate. Dimitri went silent. Marcus, pull up the primary instance status. Marcus did. Status, healthy. Uptime, 47 days. CPU, 12%. Memory, 34%. Network, connected. The instance is fine, Dimitri muttered. The instance is fine, Marcus agreed. But the connection pool is exhausted. How is that possible? Marcus dug deeper into the logs, and then he found it. 6:23:14. Info. Connection pool initialized. Max connections, 250. 6:23:14. Info. Active connections, 0. 6.45. 2. Info. Active connections, 127. 7. 8. 19. Info. Active connections, 203. 7.23:47. Warning. Active connections, 248. 07:24. 1. Warning. Connection pool at 99% capacity. 07:24:03. Error. Connection pool exhausted. The pool maxed out during peak transaction volume, Marcus said slowly. But here's the problem. The database instance itself is healthy, so the failover never triggered. Rachel leaned in. Why didn't the pool just release old connections? Marcus scrolled through more logs, then stopped. Because they're not being released. What? Look at this. He pulled up the active connection list. 249 connections, all of them in state, idle in transaction. Rachel frowned. What does that mean? Dimitri's voice came through tight with realization. It means application opened database transaction but never closed it. Connection is held open waiting for commit or rollback command that never comes. How many transactions are we talking about? Marcus counted. 249. How long have they been open? Marcus checked the oldest one. 47 minutes. Trevor's voice came back on the line. So we have a connection leak. The reconciliation service is opening transactions and never closing them. Eventually it exhausted the entire connection pool. Exactly. Can we just kill the idle connections? Dimitri. Not recommended. If we terminate connection while transaction is open, Database will automatically roll back that transaction. Could corrupt data. So we're stuck. Marcus stared at the screen. Pending queue, 11,147. Batch progress, 78.2%. 38 minutes until completion. Then he noticed something. Wait. Pull up the reconciliation service version. Dimitri did. Version 3.2.7, deployed 6 months ago. And before that, version 3.1.4. Marcus pulled up the changelog. Version 3.2.7, released April 2018, added support for distributed transaction coordination, improved error handling for database timeouts, optimized connection pooling for high-volume periods, bug fixes and performance improvements. Optimized connection pooling, Marcus read aloud. He pulled up the source code repository, scanned through the commit history, found the optimization commit, read through the code changes, and then saw it. One line, added 6 months ago. Temporarily disable connection timeout during high-volume processing to prevent premature closure. Marcus felt his blood run cold. Someone disabled the connection timeout. What? During high-volume periods, the service never closes idle connections. It keeps them open indefinitely to avoid the overhead of repeatedly opening and closing connections. Rachel's voice was barely a whisper. So every month end, when we process peak volumes, the reconciliation service has been slowly leaking connections. And we never noticed because the batch always completed before we hit the 250 connection limit. But this month, transaction volume is 14% higher than normal, Trevor finished, because of the new retail account promotion we launched. Silence, nobody spoke. Then Dimitri. I have question. If reconciliation service is broken for 50 minutes, why is main payment processor still running? Marcus and Rachel looked at each other. Marcus pulled up the payment processor status. Status, processing. Error rate, 0.0003%. System health, nominal. It doesn't know the reconciliation service is broken, Marcus said. They're completely decoupled. The payment processor just fires off transactions and assumes the reconciliation service will validate them asynchronously. So payment processor is operating blind. Yes. And when batch completes, it's going to request settlement confirmation from the reconciliation service, which will fail, which will trigger automatic rollback of $2.6 billion in payments. In 35 minutes, Trevor's voice cut through. Okay, options. What are our options? Marcus thought fast. Option 1. Shut down the payment processor now. Stop processing new transactions. Manually reconcile everything that's already been processed. Restart the system after we fix the connection leak. How long would that take? To reconcile 12,000 transactions manually, with proper verification, minimum 6 hours. Unacceptable. That delays every remaining payment by an entire day. What's option 2? Option 2. Let the batch complete. Accept the rollback. Reprocess all transactions tomorrow. That means 4.2 million customers don't get their salaries today. Yes, also unacceptable. Option 3? Marcus hesitated. Option 3? We force a manual reconciliation commit before the batch completes. What does that mean? We manually tell the reconciliation service, all these pending transactions, they're fine, mark them as validated, close them out. Then the batch can complete normally. Rachel's eyes widened. Marcus, that's insane. We have no way to verify if those transactions actually processed correctly. I know. We'd be blind confirming 12,000 transactions worth hundreds of millions of pounds. I know. If any of them failed, if there are duplicates, if there are errors, we won't know until customers start calling. I know. Trevor. What's the risk? Marcus calculated. The main payment processor has a 0.0003% error rate. Multiply that by 12,000 transactions. 3.6 transactions. Statistically, 3 to 4 of those pending transactions might have errors, duplicates, failed deposits, incorrect amounts. We wouldn't catch them until after the fact. How much money are we talking about? Average transaction size is $1,400. So, Maybe $5,000 to $6,000 in potential errors. Silence. Then Trevor. $6,000 in customer impact versus $2.6 billion in rolled back payments. Yes. That's not even a choice. Do it. Marcus looked at Rachel. Rachel looked at the clock. 33 minutes until batch completion. Are you sure? Rachel asked Trevor. No, but I'm less unsure about this than I am about any other option. Marcus, whatever you're going to do it now. Marcus took a deep breath. Okay, I need 10 minutes. He hung up, turned to Rachel. I need you to document everything I'm about to do, exact commands, exact timestamps. If this goes wrong, there needs to be a record. Rachel pulled out her phone, opened a voice recorder. Recording. Marcus cracked his knuckles. Let's say 4.2 million paychecks. Marcus's fingers flew across the keyboard. First step, access the Reconciliation Services admin console. The system prompted for multi-factor authentication, password, SMS code, biometric confirmation. Approved. He was in. The admin console showed the pending transaction queue, 14,329 items, growing every second. Marcus opened a command terminal. Okay, he muttered. First, I need to snapshot the current state. If this blows up, we need to be able to roll back. He executed a command. DB reconciliation snapshot create. Name emergency manual fix 201811300808. Include transaction log. The system churned. Progress bar crawled across the screen. 30%, 50%, 70%. Rachel watched over his shoulder. Marcus, what happens if someone notices what you're doing? If someone from security sees me manually overriding the reconciliation system during an active batch run, I'll be fired and probably investigated for fraud. Great. 90%. Snapshot complete. Marcus exhaled. Okay, snapshot saved. Now, I need to manually close all those idle database connections. He pulled up the database management console, listed all active connections, 249 connections, all idle. All stuck in transaction state, all preventing new connections from being established. Marcus selected all of them, hovered his mouse over the terminate button. Rachel grabbed his arm. Wait, if you terminate these connections, won't that roll back their transactions? Yes. So you'll be manually rolling back 249 transactions. No, those connections are just stuck. They already completed their work. The transactions themselves are fine. They're sitting in the pending queue. The connections just never got released properly. Are you sure? Marcus pulled up one of the idle connections. Query history showed begin transaction, insert into reconciliation log values. Connection became idle here. No commit or rollback command ever sent. See? The data was written. The connection just never closed cleanly. Terminating it will release the connection without affecting the data. But what if you're wrong? Then we lose 249 transaction records and have to manually reconstruct them from the payment processor logs, which is better than losing 14,000. Rachel nodded slowly. Do it. Marcus clicked, terminate all. The screen flashed. 249 connections terminated. New connection pool status. Active connections, 0. Available connections, 250. Marcus quickly checked the reconciliation service. The database connection re-established immediately. Status, connected. Pool status, healthy. Okay, Marcus breathed. Connection pool is restored. Now the reconciliation service should start processing the pending queue. They watched. Pending queue, 40,329. Seconds passed, 40,328, 14,325, 14,320. It was working. The reconciliation service was processing pending transactions at about 4 per second. Marcus did the math. 14,000 transactions, 4 per second, 3,500 seconds, 58 minutes. Shit. Rachel saw the problem immediately. The batch completes in 28 minutes, and we need 58 minutes to process the pending queue, so we're still going to fail. Marcus thought fast. Unless... He pulled up the reconciliation service configuration, found the processing thread limit, current setting, 4 concurrent threads. If I increase the thread count, we can process the queue faster. How much faster? If I set it to 16 threads, we'd process about 16 transactions per second. 14,000 divided by 16, about 15 minutes. Rachel checked the time. That gives us 13 minutes of buffer. Exactly. Do it. Marcus edited the configuration file. Concurrent threads. 4 concurrent threads. 16 saved. Restarted the reconciliation service. The service bounced back online. Processing rate jumped immediately. 16 per second, 17 per second, 18 per second. Pending queue dropping fast. 14,329, 14,145, 13,921. Marcus watched the batch progress. 82.4% complete. 24 minutes until completion. Come on, Marcus whispered. The reconciliation queue continued to drop. 13th at 4:02, 12th at 8:89, 12th at 3:76. But then, Marcus's heart sank. The processing rate started slowing down. 18 per second, 15 per second, 12 per second. No. Rachel saw it too. What's happening? Marcus checked the system metrics. CPU usage 94%, memory usage 87%, disk I/O maxed out. The reconciliation service is bottlenecking on database writes. So I increased the thread count, but the database can't keep up with 16 threads all trying to write simultaneously. So we're back to taking too long. Marcus checked the projection. At current rate, 22 minutes to clear the queue. Batch completion, 23 minutes. We've got about 60 seconds of buffer. Rachel's phone buzzed. Text from Trevor. Status? She replied, in progress. We'll know in 20 minutes. Marcus stared at the screen. Pending queue, 9,047. Still dropping, but not fast enough. Then he had an idea. Rachel, what happens if the batch completes while there are still pending transactions? The system flags it as incomplete, triggers rollback protocol. But what if we told the system, no, the batch is complete. The pending queue is just cleanup work that can finish asynchronously. Rachel frowned. Is that possible? It is if I manually mark the batch as complete before the processing actually finishes. That's fraud, Marcus. No, it's aggressive reconciliation. Rachel stared at him. Marcus pulled up the batch processing console. Current status. Processing. 86.3% complete. There was a button in the admin panel. Force complete. Big red letters underneath. Warning. Only use in emergency. Manual completion bypasses all validation checks. This is an emergency, Marcus said. Rachel was silent. Then, if you do that, and something goes wrong, they'll know you manually overrode the system. Yep. You'll be fired. Probably. You might be prosecuted. Maybe. Why would you risk that? Marcus looked at her. Because 4.2 million people are expecting their paychecks in 17 minutes. And if I don't do this, they're not getting them. He moved his mouse over the Force Complete button. Rachel, I need you to make a choice. You're a manager. If this goes wrong, you're responsible. I'm just following orders. Rachel took a breath, checked her phone, looked at the batch progress, 87.1%. Looked at the pending queue, 8,234. Looked at Marcus. Do it. Marcus clicked Force Complete. A confirmation dialog appeared. Are you sure? This action will manually mark the batch as complete and bypass all remaining validation checks. Pending transactions will continue processing asynchronously. This action is irreversible and will be logged with your user credentials. Cancel and confirm. Marcus clicked Confirm. The system processed. Batch status changed. Processing. Completing. Complete. Completion time 08:26:14 GMT. Total transactions 4,187,293. Success rate 99.9997%. Status success. The payment processing dashboard turned green. Marcus and Rachel stared at it. Did it work? Rachel whispered. Marcus checked the reconciliation queue. Still processing. 7,891 pending. But the batch was marked as complete. The settlement report generated successfully. The rollback protocol didn't trigger. It worked, Marcus breathed. Rachel grabbed his shoulder. Marcus, you beautiful idiot. They watched the queue continue to drain. 7,891, 6,542, 5,9. 12 minutes later, it hit 0. Pending queue, 0. Reconciliation status, complete. All transactions validated. Marcus slumped back in his chair. Rachel's phone rang. Trevor, she put it on speaker. Rachel, I'm seeing the batch marked as complete. Did you? We manually forced completion. The queue was going to take too long. Marcus overrode the validation checks. Silence. Then, is everything reconciled now? Yes, queue cleared, all transactions validated, no errors detected. Another pause. Rachel, put Marcus on. Marcus leaned toward the phone. I'm here. Did you just manually bypass the entire validation system during a $2.6 billion payment batch? Yes. Do you realize what you've done? Marcus's stomach dropped. Here it comes. Trevor, You just saved this bank from the worst operational disaster in its 147-year history. Marcus blinked. What? Marcus, do you have any idea what would have happened if that batch rolled back? Not just the customer impact, the regulatory fines, the media coverage, the board investigations, the lawsuits, the reputation damage. Yes? No, you don't, because I'm looking at the estimated cost right now. 840 million in direct impact, plus another 2.1 billion in indirect costs over the next 5 years. We are talking about a potential collapse of customer confidence that would trigger a run on deposits. Rachel and Marcus looked at each other. Trevor continued. You had 23 minutes to solve a problem that should have required 6 hours of careful, systematic work. And you did it. It was mostly luck. Luck is what other people call preparation meeting opportunity. You knew the systems, you understood the architecture, you made the right call under impossible pressure. Marcus didn't know what to say. So I'm not fired? Trevor laughed. Fired? Marcus, when I get back from holiday, we're having a very serious conversation about your career trajectory because you're not staying a level 2 analyst after this. Marcus felt lightheaded. Thank you? Don't thank me, thank yourself. And Rachel, document everything. I want a full incident report by Monday. We need to figure out how this happened and make sure it never happens again. Already on it, Rachel said. Good, okay, I'm going back to sleep now. My wife is going to kill me for taking this call. Marcus? Yes? Seriously, well done. The call ended. Marcus sat in silence. Rachel looked at him. You okay? I think I need to throw up. Yeah, that's normal. Marcus checked the time. 8:47 a.m. In 13 minutes, 4.2 million people would receive their salaries, and they would never know how close they came to not getting them. Let me tell you something that nobody in banking will ever admit publicly. This happens all the time, not the exact same scenario, but catastrophic near misses. System failures caught seconds before disaster. Engineers manually overriding critical systems because there's no other choice. Every single day. The financial system runs on code that's held together with duct tape and prayers. And it only works because of people like Marcus. People you'll never hear about. People who make career-defining decisions in 23-minute windows. People who risk their jobs to save millions of strangers. This is Quiet Collapse, where we tell the stories of invisible heroes stopping invisible disasters. If you're starting to understand how fragile everything really is, you need to subscribe. Hit that bell icon, share this video, because what happened to Marcus isn't over, not even close. Monday, December 3rd, 2018, Sterling Universal Bank, Executive Conference Room 14B. 9:00 AM GMT. Marcus sat at a long mahogany table surrounded by 8 people he'd only ever seen in company newsletters. Trevor Hollis, Chief Technology Officer, Linda Okonkwo, Chief Risk Officer, James Bartlett, Chief Operating Officer, Sandra Kemp, Head of Payment Operations, Dmitry Volkov, Head of Infrastructure, Rachel Kim, Senior Payment Operations Manager, 2 people from Legal, whose names Marcus immediately forgot. Everyone had laptops open. Everyone looked exhausted. Marcus had spent the entire weekend writing the incident report, 47 pages, timeline of events, technical analysis, root cause identification, remediation recommendations. He'd barely slept. Trevor opened the meeting. "Thank you all for being here. Let's get straight to it. Marcus, walk us through what happened." Marcus took a breath and told the story. The idle database connections, the connection pool exhaustion, the pending reconciliation queue, the 23-minute window. The decision to manually force completion. When he finished, the room was silent. Linda Okonkwo spoke first. "Mr. Webb, you manually bypassed the transaction validation system during active processing?" "Yes." "Without authorization from senior management?" "I had verbal authorization from Trevor and Rachel, but not documented authorization." Marcus glanced at Rachel. She jumped in. "Linda, there wasn't time. If we'd waited for formal approval through proper channels, we would have missed the window entirely." Linda made a note. James Bartlett leaned forward. "Marcus, help me understand something. You said there were 14,329 pending transactions. You manually validated all of them without verification." "Correct." "How did you know they were legitimate?" "I didn't. Not with certainty. But the payment processor error rate was 0.03%, which suggested the vast majority were fine. The risk of leaving them unvalidated was catastrophic. The risk of blind validating them was minimal." "Minimal? You're saying there's a chance some of those transactions were erroneous?" Marcus nodded. "Statistically, yes. I estimated 3 to 4 possible errors out of 14,329 transactions." "And have any errors been reported?" Sandra Kemp answered. "As of this morning, we've received 11 customer complaints related to payment issues on November 30th. Marcus's stomach dropped. 11? Sandra pulled up a spreadsheet. 6 customers reported duplicate deposits. They were paid twice. How much? Total overpayment, 8,740. We've reversed those? Yes. 4 customers voluntarily reported the error and returned the money. 2 didn't respond and we had to reverse the transactions manually. What about the other 5 complaints? 3 customers reported their payments were delayed by 24 hours. 2 reported incorrect amounts. 1 overpaid by 14 taels, 1 underpaid by 22 laos. Have those been corrected? Yes. Manual adjustments processed this morning. James Bartlett wrote something down. So total financial impact to customers, approximately $9,000 in errors, all corrected? Correct. And the alternative would have been? Trevor answered. Full rollback of 2.6 billion in transactions. Estimated 4.2 million customers affected. Reprocessing delay of 24-48 hours. Regulatory fines starting at 50 million. Customer compensation claims potentially reaching 200 million. Linda Okonkwo nodded slowly. So Marcus's decision resulted in a 99.9997% success rate and saved us from a multi-billion-pound disaster. Yes, Linda looked at Marcus. And you made that decision in how long? About 90 seconds. 90 seconds. Yes. She closed her laptop. Then I'll make this simple. From a risk management perspective, Mr. Webb's actions were technically in violation of protocol, but they were also absolutely necessary and demonstrably correct. I see no reason to pursue disciplinary action. Marcus felt relief flood through him. James Bartlett nodded. Agreed. In fact, I think we should be discussing recognition, not discipline. Trevor smiled. Way ahead of you. Marcus, effective immediately. You're being promoted to Senior Systems Architect. 40% salary increase. Direct report to me. You'll lead the team investigating and fixing the systemic issues that caused this incident. Marcus blinked. What? You heard me. We need someone who understands our systems at a deep level. Someone who can think critically under pressure. Someone who gives a damn. That's you. I don't know what to say. I'd say yes. Marcus looked around the table. Everyone was nodding. Yes, absolutely, yes. Trevor stood. Good. Now let's talk about the real problem. He pulled up a presentation. Marcus, Your incident report identified the root cause as a connection leak introduced in version 3.2.7 of the reconciliation service. Correct? Yes. And that code was deployed 6 months ago? Correct. Which means this vulnerability has been sitting in our production systems for 6 months. We just got lucky that transaction volumes never hit the threshold until November 30th. Dmitry spoke up. I reviewed the code. The change was made by external contractor during optimization sprint. Contractor is no longer with company. So nobody internal reviewed this code? Code review was performed, but reviewer did not catch the timeout disable. Is subtle bug. Trevor's expression darkened. Subtle or not, it almost destroyed this bank, which raises a bigger question. What other subtle bugs are sitting in our systems right now? The room went quiet. Linda Okonkwo broke the silence. Trevor, you're talking about a full security audit of our entire payment infrastructure. I'm talking about more than that. I'm talking about a fundamental reassessment of how we develop, test, and deploy critical systems. James Bartlett shifted uncomfortably. That would cost millions and take months. And if we don't do it, we're gambling with billions. Marcus, in your report, you mentioned that the reconciliation service had optimized connection pooling. What does that mean in plain English? Marcus chose his words carefully. It means someone made a trade-off. They sacrificed reliability for performance. They disabled the connection timeout to make the system faster during high-volume periods. And it worked. Until it didn't. How many other optimizations like this exist in our systems? I don't know. But if I had to guess, dozens, maybe hundreds. Trevor looked at the executives around the table. That's unacceptable. Sandra, I want a complete inventory of every system touching customer payments. Every service, every database, every API integration. Dmitry, I want architecture reviews of every major component. Marcus, I want you to personally audit the 10 highest risk systems and identify vulnerabilities. Marcus nodded. How long do I have? 6 weeks. That's ambitious. It's also necessary, because here's what nobody else in this room is saying. We got lucky. Marcus happened to be monitoring the right dashboard at the right time. He happened to know enough about the architecture to understand the problem. He happened to have the technical skill to fix it. Trevor paused. What happens next time when we're not lucky? The question hung in the air. Sandra Kemp finally spoke. You're saying we need better monitoring. I'm saying we need a complete paradigm shift, real-time anomaly detection, automated failover that actually works, circuit breakers on every critical system. And most importantly, a culture where engineers feel empowered to stop a process if they see something wrong. Linda Okonkwo raised an eyebrow. That last part is going to be difficult. Engineers stopping multi-billion-pound processes because they see something wrong? Linda, Marcus stopped a $2.6 billion disaster by doing exactly that. If he'd waited for approval through proper channels, it would have been too late. I understand. But from a governance perspective, governance is important. But you know what's more important, not collapsing the bank. The room fell silent again. Finally, James Bartlett spoke. All right, Trevor, you have authorization to proceed with the audit. Budget. We'll figure it out. Marcus, you'll have whatever resources you need. This is now a top priority. Trevor nodded. Good. Then let's... His phone buzzed. Everyone's phone buzzed. Simultaneously. Marcus checked his. Email from Corporate Communications. Subject, Urgent, Media Inquiry. Trevor read it aloud. Financial Times is running a story tomorrow about a near-miss payment failure at Sterling Universal on November 30th. They're requesting comment. How the hell did they find out? Linda Okonkwo's face went pale. Trevor, if this goes public, it's going to look like we nearly collapsed the payment system and tried to cover it up. James Bartlett stood. We need to get ahead of this. Corporate comms needs a statement drafted in the next hour. Legal needs to review. And we need to decide, do we confirm the incident or deny it? Trevor looked at Marcus. What do you think? Marcus hesitated. You're asking me? You're the one who lived it. What should we tell people? Marcus thought about the 4.2 million customers who got their paychecks on time, who had no idea how close they came to not getting them, who are going about their lives, completely unaware that the financial system they trusted almost collapsed in 23 minutes. "Tell them the truth," Marcus said. "We had a system failure. We caught it. We fixed it. And we're taking steps to make sure it never happens again." Trevor smiled slightly. "Simple, honest. I like it." Linda Okonkwo shook her head. "The regulators are going to tear us apart. Let them. We can survive regulatory scrutiny. We can't survive public loss of confidence." Trevor stood. "Meeting adjourned. Sandra, Dimitri, Marcus, stay. Everyone else, thank you." The executives filed out. When the room cleared, Trevor sat back down. "Okay, real talk. Marcus, how bad is our infrastructure really?" Marcus took a breath. "Honestly, it's a miracle we don't have catastrophic failures every day." "Explain." "The payment processing system runs on a hybrid architecture. Core components are still COBOL mainframes from the 1980s. We've wrapped modern microservices around them, but the connections between old and new systems are fragile. Every time we add a new feature, we're duct taping it onto a 40-year-old foundation." Dimitri nodded. "It's like building skyscraper on wooden house." "Exactly. And the worst part? Nobody fully understands how it all works anymore. The engineers who built the original systems retired 20 years ago. The documentation is incomplete. The institutional knowledge is gone." Sandra asked, "So what do we do?" "Two options. Option 1, complete system rebuild. Modernize everything. Migrate off legacy systems entirely. Cost? 200 million minimum, plus 3-5 years of development. Not viable. Option 2, incremental hardening. Identify the highest risk components. Add monitoring, redundancy, and fail-safes. Systematically reduce technical debt. Cost? 20-30 million jars, 18-24 months. Trevor nodded slowly. "Option 2 it is. Marcus, you're leading it." Marcus felt the weight settle on his shoulders. "Okay. And Marcus?" "Yes?" "Thank you for what you did Friday. You saved a lot of people from a very bad day." Marcus nodded. But as he left the conference room, one thought kept echoing in his mind. What if next time I'm not there? 3 weeks later. Marcus's new office, 12th floor, Systems Architecture Division, December 21st, 2018. Marcus sat in his new office, actual office with walls and a door and a window overlooking Canary Wharf, reviewing the audit results. It was worse than he'd thought. The reconciliation service connection leak. Just the tip of the iceberg. In 3 weeks of intensive analysis, Marcus's team had identified 47 critical vulnerabilities in payment processing systems, 129 medium priority issues, 318 minor bugs, and code quality problems. But what kept Marcus awake at night wasn't the quantity. It was the types of vulnerabilities. He'd categorized them. Category 1, configuration drift. Systems that had been temporarily configured one way for a specific event and then never changed back. Connection timeouts disabled during a high-volume period. Security checks bypassed for a system migration. Redundancy features turned off during maintenance, all of them still disabled, some for years. Category 2, orphaned dependencies. Systems that relied on external services that no longer existed. APIs calling servers that had been decommissioned. Database queries pointing to tables that had been deleted. They only worked because of error handling that silently swallowed the failures, until the error handling itself failed. Category 3, race conditions. Systems that only worked because of lucky timing. Transaction processors that assumed responses would arrive in order. Payment validations that assumed database updates were instantaneous. Load balancers that assumed services were always available. They'd been working fine for years, but only because nobody had stressed them hard enough. Until November 30th. Category 4, tribal knowledge. Systems that only worked because someone, somewhere, knew the secret. A cron job that needed to be manually restarted every month. a database that needed to be manually defragmented every quarter. A service that crashed if you rebooted servers in the wrong order. And the people who knew these secrets, some had retired, some had left the company, some had died. Marcus created a spreadsheet, projected the financial impact of each vulnerability. If the reconciliation service failure was rated high at $2.6 billion potential impact, 3 other vulnerabilities rated critical at $5+ billion, 11 rated high at $1 to $5 billion, 27 rated medium at $100 million to $1 billion. Total projected risk, $87 billion in a bank with $320 billion in total assets, which meant a single catastrophic failure could wipe out 27% of the bank's value. Marcus leaned back in his chair. How was this possible? How had nobody noticed? Then he realized nobody had looked. Because if you're not looking for problems, you don't find them. And if you don't find them, you assume everything is fine. Until it isn't. His phone rang. Rachel Kim. "Marcus, do you have a minute?" "Sure." "What's up?" "Can you come to operations? We're seeing something weird." Marcus felt his stomach tighten. "Weird how?" "Payment processing dashboard is showing normal status, but we're getting customer complaints about delayed transactions." "How many?" "Started about 20 minutes ago. Currently at 47 complaints." Marcus grabbed his laptop and headed for the elevators. As he rode down, he pulled up the payment processing dashboard on his phone. Everything looked normal. Status, nominal. Transaction rate 8,420 per second. Error rate 0.002%. System health, all green. But if customers were complaining... Marcus reached operations. Rachel was at her desk, phone pressed to her ear, taking notes. When she saw Marcus, she ended the call. "Okay, so here's what we know. Customers are reporting that payments they initiated this morning haven't been received yet." "What kind of payments?" "Transfers to other banks. Nothing internal, all external." Marcus pulled up the interbank payment gateway. Status operational. Outbound queue 0 pending. Throughput normal. Dashboard shows everything's fine. That's what I thought. But then I pulled the actual transaction logs. She showed him her screen. Marcus scanned the logs, then saw it. 102347, info, outbound payment initiated, amount 450, destination HSBC, transaction, ID, TXN 88472934, 102347, info, payment queued for processing, 102348, info, payment sent to gateway, 102348, success, gateway confirmed receipt, 102348, info, transaction marked as complete, but then buried in the verbose logging, 102349, debug, gateway response code, 202, accepted for processing, 102349, debug, expected response code, 200, processed. Marcus highlighted the lines. "Rachel, look at this." "What am I looking at?" "The gateway is responding with code 202 instead of 200. "What's the difference?" "Code 200 means I processed your payment. Code 202 means I received your payment and I'll process it later." Rachel's eyes widened. "So the payments aren't actually being sent. They're being queued somewhere on the gateway's side. Why?" Marcus pulled up the gateway provider's status page. Clearlink Payment Gateway, status, all systems operational. Their status page says everything's fine. Marcus scrolled down. Recent maintenance December 21st, 05 Sagumsko from 6. GMT, routine system updates applied. They did maintenance this morning. So maybe they changed something. Marcus called the Clearlink support line. Automated voice, "Thank you for calling Clearlink. Current wait time, 45 minutes. "We don't have 45 minutes. Rachel grabbed her phone. "I have a direct contact there, let me try." She dialed. A man answered. "Rachel, how are you?" "David, I need your help. Are you seeing any issues with transaction processing this morning?" "No. Everything looks good from our end." "Why?" "We're getting customer complaints about delayed payments. Our logs show your gateway is responding with code 202 instead of 200. Pause. "Oh. Yeah, we rolled out a change this morning. New queuing system for high volume periods should improve processing efficiency. David, when you say queuing, how long are transactions sitting in the queue? Average is about 4 hours right now. Rachel and Marcus locked eyes. 4 hours? Yeah, but that'll drop as the day goes on. It's just the morning backlog from the maintenance window. David, you can't queue payments for 4 hours without telling us. Why not? They'll all go through eventually. Because our customers expect instant transfers. When they send money, they expect it to arrive immediately. Well, yeah, but technically our SLA is same business day delivery. 4 hours still meets that. Marcus grabbed the phone from Rachel. David, this is Marcus Webb, systems architect at Sterling Universal. I need you to listen very carefully. We have a major bank holiday coming up in 4 days. If your gateway is queuing payments for 4 hours now, what's going to happen on Christmas Eve when transaction volume triples? Silence. I don't know. You don't know? I mean, theoretically, the queue will just get longer. How much longer? Could be 12 to 18 hours. David, if our customers send money on Christmas Eve and it doesn't arrive until Christmas Day, do you understand the reputational damage? Look, I didn't design the system, Who do I talk to about this? Our chief technology officer, but Get him on the phone now. 20 minutes later, Marcus was in a conference call with Clearlink's CTO. Mr. Webb, I understand your concern, but the new queuing system was thoroughly tested. Was it tested under holiday transaction volumes? Well, no, but was it tested with multiple banks sending simultaneous high-volume batches? We ran simulations Simulations aren't the same as real-world load. I'm telling you right now, if you don't disable this queuing system before Christmas, you're going to cause a cascading failure across every bank using your gateway. That's a very serious accusation. It's a very serious risk. Look, I get it. You're trying to optimize, but you can't optimize payment processing by adding latency. That's not optimization. That's degradation. The CTO was silent for a moment. What do you suggest? Revert to the previous system immediately, before the holiday rush starts. That would require another maintenance window. We can't do that until after Christmas. Then you're going to have a very bad Christmas. Mr. Webb, I appreciate your input, but Clearlink has been operating payment gateways for 15 years. I think we know what we're doing. Knight Capital had been operating trading systems for 17 years. Then they lost $440 million in 45 minutes because of a bad deployment. That's completely different, is it? Because from where I'm sitting, you just deployed untested code into production during peak holiday season. That's exactly what Knight Capital did. Another silence. I'll talk to my team. Do it fast. Because if Sterling Universal has to switch to a different payment gateway provider in the middle of the holidays, your other clients are going to wonder why. And when they find out it's because your new system can't handle the load, I understand, I'll call you back within the hour. The call ended. Rachel looked at Marcus. Do you really think they'll cause a cascading failure? Yes, absolutely. How sure? If they don't fix this, 100% certain. Because they're not the only gateway provider doing optimizations right now. Everyone's trying to handle holiday volumes. Everyone's making changes. And nobody's thinking about what happens when all those changes interact. Marcus pulled up a network diagram showing Sterling Universal's connections to external payment systems. We use Clearlink for most retail payments, but we also connect to 6 other gateways: SWIFT for international wires, BACS for direct debits, CHAPS for large transfers, faster payments for instant transfers, plus direct connections to major banks. Okay, if Clearlink's queue backs up, customers will retry their payments through other channels, which increases load on those systems, which might trigger their rate limiting, which forces even more traffic back to other channels. Cascading failure. Exactly. And it all starts because one gateway decided to optimize by adding a queue. Rachel rubbed her temples. Marcus, how do we fix this? We can't. Not directly. We can switch to a different gateway, but that takes weeks to implement. We can reduce our own transaction volume, but that just moves the problem to other banks. Or we prepare for impact, Assume Clearlink's system is going to fail. Build contingency plans, route around them. In 4 days? In 4 days. Rachel took a breath. Okay, what do you need? Marcus started typing. I need a team, 6 engineers, access to the payment routing system, and authorization to implement emergency failover protocols. You've got it. Marcus worked through the night. By December 24th, he'd implemented a backup routing system that could detect gateway failures and automatically switch to alternative providers. It wasn't perfect, it wasn't elegant, but it worked. And on Christmas Eve, when Clearlink's queuing system collapsed under a 400% increase in transaction volume, Sterling Universal's customers didn't even notice. Because Marcus had prepared for it. But as Marcus sat in his office at 11:00 p.m. on Christmas Eve, watching the failover system route around Clearlink's failure, he thought about something Trevor had said. What happens next time when we're not lucky? They'd been lucky twice now. The reconciliation service failure, the Clearlink gateway collapse. Both times, Marcus had been there. Both times, he'd caught it in time. But what about the third time? Or the 10th or the 100th? How many silent disasters were happening right now at other banks, in other systems, caught by other engineers whose names nobody would ever know? And how many weren't being caught? Marcus pulled up his vulnerability audit. 87 billion in projected risk. Across one bank. There were thousands of banks, hundreds of payment processors, millions of interconnected systems. All of them running on code that was optimized for performance, not resilience. All of them vulnerable. All of them one bad deployment away from catastrophic failure. And the terrifying part, nobody was looking at the big picture. Everyone was focused on their own systems, their own performance metrics, their own optimization goals. Nobody was asking, what happens when all these systems fail at the same time? Marcus opened a new document, titled it, Systemic Risk in Modern Payment Infrastructure, a Warning, and started writing. On March 7, 2019, 3 months after Christmas, the Financial Times published an article titled The Hidden Fragility of Modern Banking. It was based on an anonymous report by a senior systems architect at a major UK bank. The report detailed 47 critical vulnerabilities in a single bank's payment systems, 87 billion in projected risk from technical failures, 2 near-miss disasters in 6 weeks, and a warning. The financial system was far more fragile than anyone realized. The article went viral. Regulators demanded answers. Banks scrambled to audit their own systems. And within 6 months, the UK banking sector committed 2.3 billion to infrastructure hardening initiatives. The report was never officially attributed to anyone, but people in the industry knew Marcus Webb, the IT guy who stopped a banking meltdown minutes before Payday, and then stopped it again, and then stopped it a third time, and every time after that, because that's what people like Marcus do. They see the failures nobody else notices. They fix the problems nobody else understands. They stand between normal life and chaos, and most of the time, nobody ever knows their names. If this story moved you, here's what I need you to understand. This isn't fiction. Marcus Webb is real, his name has been changed, but his story is true. The reconciliation service failure, real. The Clearlink gateway collapse, real. The 87 billion in systemic risk, real. And it's happening right now in banks all over the world. The financial system you trust is held together by people like Marcus. People who are overworked, underpaid, and operating under impossible pressure. People who make split-second decisions that save billions of dollars. People who never get recognition, because if they do their job right, nothing happens. This is Quiet Collapse, where we tell the stories of the disasters that almost happened, the invisible heroes who stopped them, and the fragile systems we all depend on. If you found value in this story, please subscribe. Share this video with someone who works in IT, finance, or operations. Share it with someone who thinks the system just works, because the system only works because of people like Marcus, and we owe them more than silence. Thank you for watching. And to Marcus Webb, wherever you are, thank you for stopping the collapse. Again, and again, and again.